Coming to the next reaction, from alcohols. Now we need to prepare alkanes from alcohols by a reduction method. Now again it is of the similar type. Already we have studied such a reaction in the previous lecture. Now exactly what is going to happen is, alcohols, when it is treated with HI, one of the hydrogen will be combining with OH. Okay, H and OH, it will combine to form water. Okay, so one of the hydrogen will combine with OH to form H2O. One hydrogen will go and combine with R in order to form RH. That is nothing but alkane. And then we have 2I, it will be combining to form I2. Right? So basically we have prepared alkane from alcohol in the presence of red phosphorus at 423 Kelvin. Now what is the role of this phosphorus? Why do we need to use this phosphorus? In the previous topic also I have explained you. The reason is, whenever iodide group is present, iodide group is formed here, okay, iodine it is formed here, it has a tendency to react with alkane and then again give back what? To give back the alkyl halide. So basically, when it is reacting with alkane, it gives back the alkyl halide. So we cannot get the desired product, that is the alkane, in good quantity. Okay, so the reaction will be what? The reaction will be reversible or the alkanes will be used up. That is the reason why, in order to prevent this, I2 should be reacted with phosphorus. So that when iodine and phosphorus they react, we get phosphorus triiodide. So in this way, iodine we are what? We are removing from the reaction so that it does not react with alkane in order to form alkyl halide. Right? So basically, the role of phosphorus is what, students? The role of phosphorus is nothing but to remove the iodine from the reaction. Clear? Let us have a look on the reaction. Now this is CH3OH 2HI in the presence of red phosphorus at 423 Kelvin. Now it is again very simple. What is going to happen? One of the hydrogen will combine with carbon. The other hydrogen will combine with OH to form H2O, and 2I group will combine to form I2. And then we know that again there is formation of alkane. So we need to remove this I2. And that is the reason why we are using phosphorus, red phosphorus. Because with red phosphorus, the reaction will be this one. Okay, it will be giving us the same reaction, right? So since it will be giving the same reaction, then we will what? We can remove the iodine group from the reaction. Clear? So using the same technique, you can solve n number of reactions. Now let us quickly note down the key points. Like alcohols, okay, like alcohols, alkanone, alkanoic acid, okay, they all undergo a reduction to give alkane in the similar way. Okay, so like alcohol, alkanone or alkanals, okay, it can also be alkanal. So let us quickly have a look on the reaction. Now already we have studied alkanal, R, C, double bond O and H. Clear? Now we need to reduce this alkanal, that is aldehyde group, to alkane. So I need to add 4HI and then here it is red phosphorus at 150 degrees Celsius. Now how the reaction will take place? 4 hydrogen we have. One hydrogen will go here, one hydrogen on this oxygen, one bond will break. Okay, so basically there is addition on this carbon and oxygen. Okay, since there is a double bond, pi bond, addition takes place on both the atoms. Now one more hydrogen, we have one more hydrogen and one more hydrogen, then the other bond will also break. That means both the bonds, they are what? They are breaking between the carbon and the oxygen. Now there is no such bond. And then this thing will be removed in the form of water, H2O. Okay. And what we are left with, students? We are left with RCH3. Clear? Okay. And then we have a 4 iodide group. So it will be removed in the form of iodine molecule. And since we have 4 iodide, so 2I2. Okay, so 2I2. So basically what we have done, we have converted alkanal to alkene. Okay, alkane. Coming to the second one, let us have a look on alkanone to alkane. Now again of the similar type, like alcohol only, the same way we are going to carry out the reaction. Now alkanone is basically the ketonic group, right? So alkanone is what, students? It is the ketonic group. So what is the general formula for ketone? We know that it is R, C, double bond O and R. Plus over here we need to add 4HI, right? And then again red phosphorus at 150 degrees Celsius. What is going to happen? The same way, 4 hydrogens we have, we are going to what? We are going to add 4 hydrogens across the double bond. And where is the double bond, students? We can see it is between the carbon and the oxygen. There is a double bond, right? So there is a double bond between carbon and oxygen. So I need to simply add hydrogen, hydrogen, one bond will break. And again, if I add hydrogen and hydrogen, the other bond will also break. So basically, both the bonds are now breaking. And then this thing will be removed in the form of water. Okay, so it is H2O. We have R, CH2 and R. Clear? And then what will happen to 4 iodine group? So it will be 2 iodide. Okay, 2 iodine molecule, it will be removed. Clear? So this is basically alkanone getting converted to alkane. Let us have a look now of the similar type. Let us take alkanoic acid. Alkanoic acid, when it is treated with red phosphorus, we get alkane. Now how we are going to proceed? It is again of the similar type. I'm going to write down the structure of alkane first, right? So the structure of alkane will give me R, C, double bond O and H, O, H, okay? Plus, we need to add 6 HI, okay? I need to add how many HI? 6 HI, then red phosphorus, and then 150 degrees Celsius. So basically, there is reduction taking place. So how the reduction will take place? Again, the same way, I'm going to add all the hydrogen, okay, across the double bond, okay? So this is hydrogen, hydrogen, then one more hydrogen, hydrogen. Both the bonds will break. And if both the bonds are breaking, it will be removed in the form of water. Okay, it will be removed in the form of water. And then the major product will be RCH2OH. And the major product will be, now before writing the major product, I need to remove this OH as well. Okay. So when this OH will be removed, students, again, if I add one hydrogen here and one hydrogen here, the single bond will also break. Okay. The single bond will also break from here. And then this OH and H, it will be removed in the form of water. So basically, we are what we are doing? We are just removing water. So how many waters we have removed? 2 water molecules. Okay. And then we are left with RCH3 plus 2 water molecules. And how many hydrogens we have added? 1, 2, 3, 4, 5 and 6. And how many hydrogens we had? We had 6 hydrogen. Now what we are left with? We are left with the 6 iodide group. And then those 6 iodide group in the form of I2 if I write down. So total 6 we want. That means 3 you need to multiply. Clear? So this is how we are going to convert alkanoic acid to alkane. And always remember, if you are preparing alkane, definitely what you need to do, you need to add a red phosphorus. because the presence of a iodine group will again give back the reaction, or the reaction will be what in the reverse manner, wherein the alkane will be getting converted to alkyl halide. So this was entirely related to the preparation of alkane from alcohol, right? So we have covered the entire thing related to preparation of alkane from alcohol. In the next lecture, I will be covering few more interesting reactions. So keep watching all the lectures and I'll see you in the next lecture.